Design of an improved double-barrel cassava grating machine. Abstract. This work presents the design of an improved double-barrel cassava grating machine. The need for ease and hygienic processing of cassava has made researchers sought for better and faster way in processing cassava. Hence, for a smooth cassava processing system, a proper design that can guarantee capacity and efficiency should be available for fabricators. Research so far have shown that there are more of single-barrel cassava grating machine. In order to obtain the same quantity of grated cassava, an increased number of barrels have been designed. The design made use of Autodesk Inventor professional software to produce the CAD model of the machine. Result of the fatigue simulation on the grater shows damage percentage of 1.667 times 10 to the power of -3 at a maximum 6.000 times 10 to the power of 7th life cycle. Statice analysis on the structural base shows a small deflection 0.01074 at the load of 1094 N. Rigidity of the machine frame was found to be 104.7 times 106 N/M. Keywords: cassava, computer-aided drafting, CAD, grating. Introduction. In developing countries, cassava has become a major staple food providing the basic diet for over 500 million of world population. Grubben et al., 2014, Okonkwo et al., 2019. The root starch for cassava, which has been the core for its cultivation, is mainly used as food, 48%, and feed, 34%, feedstock, 18%, and for biofuels and as well as biochemicals, FAO, 2008. Of all root tubers, cassava has been the most perishable, and when the tubers are separated from the main plant and turns out to be unpleasant within 2 to 3 days after harvest, thereby undergoing post-harvest physiological deterioration. IJERT 2006, Okonkwo et al., 2019. Hence, it is necessary to process the crops within 3 days after harvest. Processing the tubers into pulp form is known as grating, FAO 2005. Various traditional methods of grating fresh cassava includes pounding with pestle and mortar, and also the use of hand graters. Making use of hand graters is quite laborious, time-consuming, and also dangerous. Cassava grating machines have been designed and also made available on the market. Some of these grating machines include pedal-operated engine, dual operational mode machines, the International Institute of Tropical Agriculture, IITA, 202, the John-type grater, the Gratis Foundation, GF, IITA 202, and the double-barrel cassava grating machine, FAO, 2005. However, these machines have been widely regarded as inefficient, Colawale et al., 2010. Due to poor quality of the products, and low efficiency of the technologies, which is a major constraint to the inefficiency of the machines, Key et al., 2009. A modern approach which responds quite well to the necessity of mankind is necessary for modern agriculture. This makes it necessary for an advanced mechanized grating machine which will really help in producing sufficient quantity and quality of cassava pulp that will meet market demands and standards. This study was carried out in order to design and improve a double-barrel cassava grating machine. The study was achieved through the study and developing a mechanism of a double-barrel cassava grating machine and developing a 3D CAD model of double-barrel cassava grating machine using Autodesk Inventor Professional. In this work, an improved double-barrel cassava grating machine will be designed. The study will be achieved through the development of mechanism of a double-barrel cassava grating machine and developing a 3D CAD model of double-barrel cassava grating machine using Autodesk Inventor Professional. 2. Literature review. Over the years, the need to transform cassava root to pulp for gari production has led to invention of several cassava grating machines available today. Hence the trend of consistent research works has characterized the progressive development of the grating machine. This machine consists of machine frame, electric motor, chute, grater, pillow block bearing, hopper, etc. These research works and investigations have the common objective of providing optimum cassava grating machine suited for gari processing and which offer the most favorable collection efficiencies at minimum cost. In other cater for the group of gari producers who have no access to electricity and or lack the resources or know-how. Odigba, 1984, designed a manually operated cassava grating machine. Also, Ndalaman, 2006, focused on power failure problems by developing a grating machine that can be powered either electrically or manually. Adetunji, and Quadri, 2011, designed and fabricated an improved cassava grater. The work modified the design of the existing cassava grater, dimensions, to the home use small scale sizes and to change the crude wooden drums used in cassava grating machines to lasting stainless steel and galvanized pipe. IJERT, ETAL, 2013, worked on design and fabrication of a home-scale pedal-powered cassava grater. Erratic power supply, scarcity, and high cost of petroleum products necessitate the need to address the issue of cassava grating to a certain extent by developing a mechanism that will make life easier in food processing for rural dwellers and improve their economic well-being. With the concept of commercializing grating of cassava, Oriaku, ETAL, 2015, designed and evaluated the performance of a double-action cassava grating machine, while Okonkwo ETAL, 2020, optimized a similar system with the aim of achieving a very high throughput in cassava grating and at a reduced grating time. 3. Methodology. Description of the designed double-action grating machine. The double-barrel grating machine consists of 1. Structural base, 2. Discharge chute, 3. Inlet hopper, 4. Bearing, plumber block, 5. Grating shaft, 6. Belts, 7. Pulleys and idler, 8. Bolts and nuts, 9. Electric motor, 10. Rivet pin, 11. Barrel, 12. Perforated stainless mesh. The overall length of the machine is 962.086 mm, width of 520 mm and height of 908.877 mm. The large trapezoidal hopper has a large area of 330 x 963.622 mm, the base area of 330 x 532 mm and the height of 348.716 mm. The grating barrel diameter 182 mm and a length of 300 mm. And the structural frame was made with 60 x 60 x 5 mm thick angle iron of top length 528.493 mm, base length 738.148 mm, slant length 619.565 mm, width of 450 mm and height of 624.428 mm. Principle of operation. The primary rotation of the electric motor is essential for the powering of the grating machine. The two grating barrels rotate in the same direction, which is clockwise. The motions of the grating barrels are transmitted through the V-belt, pulleys, shafts, and bearings by the torque of the electric motor. The shaft is attached to the grating barrel and peeled cassava is fed into the machine through the hopper, which makes contact with the rotating grater barrel. The rotating grater then reduces the cassava tuber into pulps. The grated pulp drops through the little gaps between the grating barrels and hopper plates through the inclined exit channel and then into the receiver. Design considerations. The consideration for the design is to attain lightweight with high rigidity, easy installation such as assembly, disassembly and operation, and cost reduction, and also to achieve reduced grating time with high throughput. Design approach. From the evaluation of the forces, determination of the bearing reactions, maximum bending moments, max, and other stress analysis of the shaft were performed using Inventor professional software, educational license, and are shown in the figures below. Discussion. Most mechanical systems have many standard components that makes up the machine. Hence, it becomes imperative to use computer-aided engineering software for the design and optimization of mechanical components. Autodesk Inventor Professional, which is equipped with component generators like shafts, bearings, gears, belt and pulley. The use of such component generators aid in the proper designing of machines. From the frame design, it was observed that the maximum load which can be loaded on the machine can have insignificant effect on the frame, thereby making the machine too highly rigid and will minimum vibration effect. For conclusion. In this study, an improved double-barrel cassava grating machine has been designed. Materials used were carefully selected with reference to the best global health practice. With the careful utilization of Autodesk Inventor Professional CAD software, and application of the basic engineering design principle, the machine was designed to grate cassava in minimum time with high throughput and also experience minimum vibration when in operation. The design also ensured easy of assembling and disassembling, thereby making easy to be used.